This particular example basically is a conventional transfer point, basically head pulley with a belt cleaner primary and secondary. The problem with this particular application is material being heavy laden with moisture content will accumulate into the head chute, basically start climbing on itself and get up into the head pulley and into the cleaners, causing a huge fugitive material housekeeping issue, in which manual intervention has to be implemented to keep the material flowing and also cleaning up the material that's not going where you actually want it to go. So what we've done here is we utilized air cannons to proactively keep the area clean and prevent material buildup. And I said one word: proactive. In the air cannon world, proactive, not reactive. We keep things clean and moving and stay ahead of the buildup. That's rule number one. But as you can see in this particular application, this is what the plant was dealing with material building up inside their head chute. And we were able to not only put in air cannons, but we can also use certain type of nozzles where we can shape that air and sweep slopes versus a blowpipe. So we have different types of nozzles that we can utilize to attack those type of accumulations, and again, be proactive and not allowing that material to build up, causing issues.
What we don't show is the nozzle location, but basically with head chutes, there can be many different ways of placing the cannons to kick out the foothold, but that's the name of the game. We're going to kick out the foothold where this material builds and stacks on top of itself. So not every two places are exactly the same as far as their buildup.
Good point. That's a great point, because a lot of times that material will react differently. So a lot of times when we actually look at an application, we're going off the information provided by the plant of where that accumulation is starting. Again, just like Masterson elaborated on, removing that foothold and allowing that material to build.